Hi guys, I'm Teja. I'm an application engineer here at Maxim Integrated. Have you ever wondered to create a bidirectional voltage source or voltage adder circuit that is easy to implement and safe to use? Well, today we are going to implement using MaxRef design boards MaxRef-1132 and MaxRef-1141, which uses flyback converter topology. Now, without further ado, let's begin the fun. Isolation in power electronics is exchange of power between two systems through an insulated medium which prevents the alternating current, noise, direct current from being physically in contact between the two systems. Now, consider a system with high voltage and other system that requires safety and protection. For isolation, the two systems has to be separated through an air-gap medium that can communicate with each other and can exchange power without direct contact. Isolation is used in electronics to provide safety to the equipment's functionality, eliminate the unwanted noise and voltage spikes that affect the device functionality. It is less efficient compared to the non-isolated topology, but it has an advantage of safe operation, reliable and non-hazardous. The table briefs the electric current intensity and its influence on human body for a various range of currents. Electrical isolation is used in diverse industries with broad range of applications and products. In communication sector, the isolation is used to remove noise from transmission signal and eliminate effect of ground loops so that the receiving end, the signal is clean and differentiated from the noise and disturbance. In industrial applications, isolation plays a major role in isolating the equipment and human from dangerous voltages so that the machines and workers are safe and protected. In medical and healthcare applications, the measuring equipment or the equipment in contact with the human body must be isolated from spikes, high voltage source so that there is no influence on human body. In automotive, with electrical vehicles getting attraction, the vehicle and its part are to be isolated. The microcontroller, the high voltage battery source, control system, the powertrain sensors should be protected all times from danger. Electrical isolation is classified based on technology used for isolating two systems. They are optocouplers, transformers, capacitive, and digital isolation. Optocoupler topology. In optocoupler, the isolation is achieved through the light-emitting device like photodiode, which transmits the signal across the air-gap barrier, and photosensor detects the radiated photons and the signal is captured at the output. Light intensity is proportional to the measured signal. In transformer, the basis of isolation is using electromagnetic field that transmits the signal from one winding of the transformer to another winding through induction. The electromagnetic intensity defines the measured signal. In capacitive, the capacitance stores electrical energy between two plates which can be used to transmit the signal across two plates. The electrical field intensity is proportional to the measured signal. In digital isolation, during the manufacturing of the IC, the isolation, either digital or capacitive, is introduced across the pins so that the signals can be transmitted within this chip. Each of this isolation, the air gap, is used as a medium for power transfer. The board has flyback transformer for isolation, power transfer from the input to the output, and optocoupler for feedback and control circuit. MaxRef-1132 is rated for 2 watts with 5 volt output and 400 milliamps of output current. Max1141 is rated for 2.4 watts with 24 volt output and 100 milliamps of output current. Case 1, we connect Vout of MaxRef-1141 and ground 0 of MaxRef-1132 for common ground. We have 3 configurations: plus 5 volt, minus 24 or 29 volts. In case 2, we connect ground 0 of MaxRef-1141 and Vout of MaxRef-1132 for common ground, and we have 3 output configurations: minus 5, plus 24 or 29 volts for the combined output. While connecting in either of the cases, please ensure that you do not exceed the rated current capability of the respective board. As it seems, one of the board might have larger current drive capability, but exceeding beyond the rated current of a board with least current drive capability might induce voltage stress and other effects on the switching circuit. Now, we are having a common input for both of the boards. So, we are going to test the board at same input voltage. Vin goes to the Vin of MaxRef-1141 and the common ground input of the both boards. these are the inputs to the both of the boards. We are connecting the boards as mentioned in case 2, wherein the ground 0 pin of max ref des 1141 goes into the Vout pin of max ref des 1132 for the common ground. Now the load is applied, and also like we have configured based on case 2, and as you can see the voltage across max ref des 1141 is 24.2, and the combined voltage output connecting the multimeter positive to Vout of max ref des 1141 and ground 0 of max ref des 1132, it's 29 volts. And when you connect the multimeter from ground 0 of max ref des 1132 and the common ground on the other board, you can see minus 5 volts. If you have a negative load, you can drive the load for the rated board current capability. So this is it guys. You can learn more and can explore more using Maxim reference design boards. Stay tuned for more videos.